We're doing Unit 5, Module 3. So we have finished Module 2, and the last lesson was actually a game, and we won't be able to do that, so we're just going to jump right into Module 3, starting off with area and perimeter. All right? So Unit 5, Module 3, Sessions 1 and 2. We're going to combine them because they are measuring area and perimeter, and it's two things that we've talked about before, so I figured why not put them in the same lesson so that we can just, move on, okay? So before we start though, here are the answers to your homework from yesterday. So you can see them sitting here. Number 1 had 0. Number 2 had 1 line of symmetry. Number 3 has 2 lines of symmetry. Number 4 has 0 lines of symmetry, and number 5 has 1. And then for 6A, it was 150. For 6B, it was 390. For 6C, it was 90 degrees. And for 6D, it is 3. Okay. And then answers to student book page 192. That third triangle right there is the one that would belong with the other ones. It has a right angle, just like the other ones do. And then also, what is the name for this kind of triangle? A right triangle, okay? And for number 2, again, that third one would go along or have something in common with the ones in the box. How do you know that? Because it has 2 pairs of parallel sides, and all 4 sides are the same length. And what is the name of this kind of quadrilateral? It is a rhombus. Okay, so in this session, we will review the term area and work together to generate a formula for determining the area of rectangles and squares. In the process, we will have an opportunity to see and handle a square inch and a square foot. Then we will apply the information as we find perimeter of various things. Okay, so here is area. All right, so area is the total number of square units needed to cover a 2-dimensional surface. So remember back at the beginning of the school year when we made those area models to help us multiply? We also talked about how the area of a rectangle is length times width, okay? Length times the width, okay? So if you can look right here, remember that we use those linear units, and we would put them along the side when we were using our blue flats. Do you remember that? Our blue single units, okay? We were helping ourselves determine the area of something. So the area of this would be 2 times 5. So that would be 10, right? Okay. I know that's not a 5, sorry. Okay. Anyway, I just wanted to show you that so that you can kind of see what I'm talking about here. And then with area, think of the space a rug takes up. So it's flat, right? And think about the space that a rug just takes up. That is what we want to think about with area, okay? All right. Then you have perimeter. Perimeter is the distance in linear units around a 2-dimensional flat figure. The perimeter of a circle is called the circumference. Remember that perimeter would be like walking around the outside edges of a garden or of a room. And then think back to the beginning of the year when we would make perimeter with those little red linear units, just like I showed you a little bit ago. But this time we also did it where we made them go all the way around. So if we were talking about perimeter, we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the distance around would be 14 units, okay? So it's kind of just counting all the way around something. All right. Okay, so that would be your little recap on area and perimeter. All right, so the tricky thing about this is that you were going to be doing this activity all together with the class. We were going to get rulers and partners and do this activity together. But since we aren't able to be together in the classroom, I will be providing you the measurements of various items, and you're going to find the area of these particular things. Okay, so what you're going to need is a pencil, and you're going to need student book page 193. Okay, so I want to show you something first before we start. That a piece of blue construction paper, the length is 18 inches, the width is 10 inches, okay? To find the area, we would put 18 times 10, and that would be 180 square inches. I want you to notice something, that when it says when it says, let me erase that real quick, that's going to get in our way. When it says 18 inches, you see the quotation mark? So quotation marks are inches. But when you see something that looks like this, an apostrophe, that stands for feet, okay? So don't let that confuse you. All right. However, this piece of construction paper would be 18 inches by 10 inches, okay? So then when you are finding area, you always put inches squared. So you might put inches squared like that. Or you'll notice that in the example box right here, it says square inches. Either way, you want to think back to when we were looking at the area models from the very beginning of the lesson and how you actually have those squares. That's what that means. It's that space that it takes up, okay? So that's why whenever you find area, you always do square, okay? If you were doing feet squared, it would be feet squared or square feet. It means the same thing, okay? All right, so I'm going to turn to the next slide, and it has all of the measurements that you would possibly need to solve this, okay, to complete this, okay? We're going to do the first few together, and you're going to do the rest of them on your own, all right? Okay, so let's talk about your math journal for a minute. All right, so your math journal is approximately 11 inches by 8 inches, okay? So to find the area, we would put 11 inches times 8 inches, and altogether 11 times 8 is 88 square inches, okay? So that's how we would do that, 88 square inches. For your desk or table, we're just going to pretend, okay? So I just measured a table that I had at home. So the length is 46 inches and the width is 38 inches. So we would take length times width, so 46 inches times 38 inches, and figure out what that is, okay? Now, if you need to use the side to help you, use the side to help you. So we're going to go ahead and do 46 times 38. Okay, so 6 times 8, that is 48, okay? And then 8 times 4 is 32. 32 plus 4 more is 36, okay? I'm going to change colors so that I don't get confused. I'm going to cross this out. I'm going to cross this out, and I'm going to automatically put my mandatory 0 because I'm moving over to the tens place. And now I'm going to do 3 times 6, which really is 30 times 6, okay? So 3 times 6, that is 18, okay? And then 3 times 4, that is 12, plus 1 more is 13, okay? And then I'm going to add them together. 8 plus nothing is 8. 6 plus 8 is 14. 3 plus 3 is 6, plus 1 more is 7. And then I bring my 1 down. And I have my answer, okay? It is 1,748. 1,748 square inches. And remember that I could put that IN with that 2 also, okay? I think I'm going to do maybe 2 more with you, and then I'm going to have you do the rest, okay? All right. A geoboard. All right. So a geoboard, that one is interesting because notice that it is a square, all right? So your geoboard would be 7 inches times 7 inches. Well, that's easy. 7 times 7 is 49 square inches. Okay, I will do 1 more with you, and then you're going to do the rest on your own, okay? All right, so the calendar grid pocket chart. Now this one is a little different because it is in feet and not inches, okay? So the length is 5 feet times 3 feet. Our pocket chart for calendar for number corner is pretty big. 5 feet by 3 feet, that is 15 square feet, or 15 feet squared, okay? So I'm going to have you do the rest of these on your own in your workbook, all right? And then upload that into Seesaw. Okay, moving on. All right, student book page 194. Number 1, Frank bought a rug for his room. It is 60 inches by 40 inches. What I would do first if I were you is I would actually draw the rug that he bought. And I would also highlight this important information, 60 inches by 40 inches. Okay. And highlight. So my 60 inches by 40 inches. It's always good to have a visual, okay? What is the total area of the rug in square inches? Use labeled sketches, numbers, or words to solve this problem. Well, I know that area equals length times width, okay? So area equals 60 times 40. I know that 6 times 4 equals 24, which means that 60 times 4 must equal 240, which means that 60 times 40 must equal 2,400. Okay, so the area of the rug that Frank bought for his room is 2,400 square inches. All right, so that's how you would do that one. All right, for the next one, the school gym is 80 feet by 50 feet. I'm going to draw that for you. You, my friends, are going to solve for the area, okay? All right, so the school gym, now you're working in feet, okay, is 80 feet by 50 feet. You're going to want to solve for the area. Remember, the area equals length times width. All right. And then you also have the challenge. Lisa's room is 90 inches by 90 inches. And she bought a rug for her floor that is 50 inches by 40 inches. How much of the floor is not covered by the rug? You're going to have to find the area of both, and then you're going to have to do some subtracting, okay? I know you can do it, though, and I can't wait to see what you come up with, all right? Okay, we're going to move on to the next page here. All right, so you probably want to pause the video here. Go ahead and complete the seesaw activity on student book page 193, and I want you to complete student book page 194 before continuing the video about perimeter. So again, you have a seesaw video to complete, student book page 193 and 194 before you continue, because we've just completed our area section and we're going to move on to perimeter next, okay? All right, so I'll give you a little bit of time to get all situated and ready for the next part. Pause the video and then come right back and let's finish, okay? All right, you should be back from uploading your seesaw activity and completing those 2 pages in your workbook, okay? Now we are moving on, okay? Alrighty, so here we go. Okay, so with this page, I want you to open up to student book page 195. I'm going to start you off and do the first 3 with you, and then you're going to do the last 5 on your own, okay? So you'll notice that we have the same, we have the same, sorry boys and girls, the same measurements that we had for a lot of these things, but now we're trying to figure out what perimeter, I'm sorry, I lost my train of thought there. What we want to use, I can't think of the word. Formula, that's the word. Formula we want to use. Sorry, little Kenny distracted me here. Apparently he wants his mommy. But we have 3 slides left to go. So for the math journal. All right, so notice that you have 2 different formulas. I'm going to show you both of them. One of them is P, perimeter, equals 2 times the width plus 2 times the length. And you typically put those in parentheses to kind of help you out. That is when you have a rectangle that you're working with. Okay? When you have a square that you are working with, you're going to use that perimeter equals 4 times the sides. And you use that for square because we know that a square, all of the sides are going to be the same length, right? Which means that we can use that instead. We can multiply the sides by 4 to know what the answer would be. Okay, so let's take a look at our math journal here. And we are doing 11 inches and 9 inches for our math journal. So first we have to decide which formula do we want to use. Well, 11 by 9, that's 2 different measurements, which means that it's not a square, it's a rectangle. And if I know that it's a rectangle, then I know that I need to use this formula and not the other formula, okay? So now I'm going to solve for this formula. So my math journal is, let's see here, perimeter equals, and I'm going to have to go off the page a little bit. You may have more space than I do, okay? 2 times 11 plus 2 times 9, okay? Now I'm going to figure out what that is. 2 times 11 is 22, okay? 2 times 9 is 18. All right, so I got to figure out what is 22 plus 18. I have a guess, okay? Let's see if my guess was correct. Okay, my perimeter equals 40 inches. Now, I do not have to square my inches because I only do that for area when I'm talking about space. When you're talking about perimeter, remember that's just a distance around something, so it's not taking up that space in the middle, it's just the distance around the outside, okay? So I don't square it, so my answer is 40 inches. You want to kind of get into the habit of circling your answer when you're done too. It's just a good habit to get into when you're doing a test and things like that as well. All right, I'm going to use a different color just so we don't get confused. Your desk or table. So notice that the measurements are a little different this time. We have 2 by 3. Again, that is a rectangle, okay? Which means that I'm going to use the top formula again, okay? I only use the bottom formula when I'm talking about a square. All right, so perimeter equals 2 times 2 plus 2 times 3. All right, perimeter equals 4 plus 6. So the perimeter of my desk or table is 10 feet. That's it. Not 10 feet squared, remember, because we're talking about perimeter and not area. Okay, we're going to do one more together, and then you're going to do the rest of these on your own. Alrighty, let's change colors again. Whoopsie, but I forgot to circle my answer. So hold on a second. Here we go. Okay, my answer is circled. And I'm moving on. Okay, my geoboard. Ooh, 7 by 7. I officially now have a square. I did that on purpose so that you could see that I'm going to use this formula because it's a square, okay? Perimeter equals 4 times the sides. Perimeter equals 4 times 7. The perimeter of my geoboard is 28 inches, boys and girls, okay? I'm going to circle that answer. And I would like for you to do 4, 5, 6, 7, and 8 on your own, okay? Great job. So if you need to look back at this video to help you, remember to do that. And remember that there are those 2 different formulas. One of them, remember, is for when you're using a rectangle, and one of them is for when you're using a square, okay? And remember what the difference is between the 2. It should be pretty simple, but sometimes we forget, right? Okay, moving on. Okay. Thinking about area. This is student book page 196. We have to determine the area of each rectangle below and write the area inside of the rectangle. All right, well, I'm going to just start us off here, okay? So the area of this first one, 3 times 3, whoops, I want to use a color that's actually going to show up. So 3 times 3, 9. No big deal, right? Okay, the area of the next one, 3 by 6, that's 18. Okay, the next one, 3 by 12. That is 36. Now, you should be noticing a pattern here. I see it. I don't know if you see it, but 3 doubled is 6, and 6 doubled is 12. The other thing I notice is that 9 doubled is 18, and 18 doubled is 36. We have a pattern going on here, boys and girls, okay? All right, moving on to this next one here, 3 by 24. That's very interesting. Well, 24 is 12 doubled, which means that my area must be 36 doubled. Yes, it is. All right, my answer, my friends, is 72, okay? 72. Now, look at the rectangles above. What happens to the area of the rectangle when one of the dimensions is doubled? All right, I'm going to write my answer. When one of the dimensions is doubled, the area is also doubled. Okay, number 2. Determine the area of the rectangle below. What is the area inside the rectangle? Okay, so I think it would be easier to kind of start over here this time because I don't want to go backwards, I want to go forward. I'm going to start with what's easier. All right. So 4 by 4, that is 16. Okay. This is an 8. I know it's really difficult to see for you, but in your workbook, you can probably see it better than I can see it on this page here. 8 by 4, that is 32. 16 by 4. Oh, here we go again with the same situation that we just ran into a little while ago, right? I'm noticing a pattern again. Do you see the pattern? 4 doubled is 8, doubled is 16, doubled is 32, right? 16 doubled is 32. 32. Ooh, boys and girls, what is 32 doubled? Think about it for a moment. Think, think, think. Oops, 6. Whoopsies, wrong. Mrs. Sanders. Oh my gosh. We're not going to write with highlighter. We're going to write with actual marker here, okay? 32 doubled is 64, okay? 64 doubled. Well, I know that 6 doubled is 12 and 4 doubled is 8. So it must be 128. Okay. So look at the rectangles above. What happens to the area of the rectangle when one of the dimensions is halved? When one of the dimensions is halved, the area is also halved. Okay. Now here, my friends, is the challenge. Okay. This is where it gets tricky. What happens to the area of a rectangle when both dimensions are doubled? So start with this rectangle and then draw and label 2 more rectangles. Well, if I've got 3 and 5, I'm going to start you off, but you're going to finish it, okay? If I double 5, I have 10. If I double 3, I have 6, okay? If you were to draw another rectangle, you have to double the 10 and double the 6. You, my friends, are going to figure out what the area is of each one. Again, figure out the area of this one, the area of this one, and what this is doubled, and find the area and answer the question. And then post that into Seesaw when you're done, okay? All right. You also have Home Connection Book, page 103 to do on your own, and Home Connection Book, page 104 to do on your own. You are going to do a fabulous job. I am proud of you. This isn't going to take you that long anyway, because if you look, there's not a lot on there, okay? All right. So do the best that you can do. If you have any questions, let me know, and keep up the awesome work. I miss you guys.